Hello and welcome to our next installment of Math Examples. We are moving right on to 8.2 Day 1. Here's your problem of the day. I am going to graph both of these equations and see if we get an answer. Okay, my first equation has 1/3 x minus 3. I'm going to start with the y-intercept. Remember, y equals mx plus b. B is your y-intercept. M is your slope. And slope looks like a fraction, remember? A fraction that is rise over run. So we like fractions. Top part tells us to go up or down. Bottom part tells us to go left or right, depending if it's positive or negative. So I like to start with the y-intercept because that tells you where to start your equation. So it starts at -3 on the y-axis. The y-axis goes up and down. The y-axis on this one, so -3 is not up here. These are all positive numbers. So my -3 actually start down here. 1, 2, 3. Next, I'm gonna my slope tells me where to go. So 1/3. 1 is my rise, so it's a positive 1, so it's gonna tell me to go up. So I'm gonna go up 1. 3 is also positive. On the x-axis, do the positive numbers go to the right or do they go to the left? They go to the right. So from here we go up 1 because the positives are up here. Negatives are down here. So I'm going to go up 1, right 3, and make it down. And I'll try to do that one more time backwards. I'm going to go opposite, down 1, left 3. See how it makes my line. And from there I am going to connect my dots. Now when I say connect my dots, I don't literally mean connect the dots like you're making a picture. You do not do this. I mean connect your dots as in make a line through your dots. That's the only way you're going to be able to see if you have an answer. So, first equation done. I'm going to move on to my second equation. Again, I'm going to start with the y-intercept, and I got a +1. So my positives are on the top part of this graph, on the y-axis. Start at +1. Ignore my dog. Next, I have a -x. This just means there's a -1x. And remember, we can change any number into a fraction by putting it over 1. So I have -1 over +1. -1 tells me to go up or down. Where are the negatives? The negatives are not up here. There's no negatives up here. So I have to go down. So I'm going to go down 1. And now are the positives to the right or are they to the left? The positives are to the right. Sorry. They are to the right. So I'm going to go down 1, right 1. Notice my slope is going downwards. That means I have a negative slope. I'm going to keep going and like bam, hit that one. I'm going to keep making my lines. Remember on Nearpod or on Teams, you guys can leave these dots and you do not need to connect them, so you don't worry about squiggly lines. Since I have time and a ruler, I'm going to connect my lines. Okay, we're not done. The last thing is we need to write the answer, which is this ordered pair. Here's my dot I need to write the location for. Location for a dot is called an ordered pair. So I have parentheses. This is my x. This is my y. Lately, you guys like to flip-flop these. When I say x first, you have to put your pen on the dot. On 0. Now, x goes first. X goes left or right, not up and down. So from 0, how far do I have to go to the left or right to get to that dot, to line up with it? Well, I can't go to the left because there's no dot here, the dot I want. So I'm going to have to go right, and I have to go right 1, 2, 3 times. I am now lined up perfectly with this dot. So I have to go right 3. So that means it's a +3 on the x-axis. I traveled on the x-axis. Next, I have to go and actually get on the dot. So now do I have to go up to get to the dot, or do I have to go down? I have to go down. So I'm going to go down 1, 2. 2 spaces to go down, and down is negative, so it's going to be -2. I went up and down. Up and down is the y-axis. See, y goes up and down. So if I go up and down here, that means it's my y. So this is my final answer, 3 comma negative 2. So that is your problem of the day. Today we are moving on to a similar topic that we've been doing, but for those of you who are not a fan of graphs, we are ditching graphs for right now. And we are moving on back to algebra. So here we go. We're going to do exactly what you've been doing. So when you graphed your graph here, we got an answer. But you got it by drawing and making lines. You got this answer. You're going to get this same answer now, but algebraically, meaning I'm going to solve it mathematically here. So we have a new set of steps. Some of the steps are now more combined because you already learned how to solve for an equation. So if you need extra steps, refer back to your previous lessons. So let's get on with it. So we have use substitution to rewrite an equation. So substitution, some of you, this might be a new word for you. Maybe if you ever go to McDonald's, Burger King, some restaurant, and maybe you don't want the fries, and maybe you want onion rings instead. Do you know what that's called? Or do you just ask them, hey, can I get these instead? Can I get the onion rings instead of the fries? Or you can be fancy and say, hey, I'd like to substitute those onion rings for my fries. So you're substituting, you're switching things out. You don't want something, we're going to switch it out for something else. So, and they're usually of equal value. You can't switch out. Normally if you switch out your soda for a milkshake, you have to pay extra for the milkshake because it's not the same price as the soda. So we are going to be, when we do substituting right now, like in math, they are equal values. So I see that y equals this equation, and I also see y equals this equation. It says y, we have two answers for y. These are both, y equals two different things. So I am able to rewrite this equation, and we're going to go from two equations to one. So I'm going to take, basically we're taking the y's out, and I'm going to set each equation equal to each other. So I got 8x, I'm going to rewrite this one first, 8x plus 13 equals, and now I'm going to write this equation, because they equal each other. Why? It's the same thing. So now some of you are like, well, Ms. Abbott, these aren't the same. Correct. They are not the same. But it's like me telling you that buying an apple and buying an orange is the same thing. But there are different things that you're buying, but they're the same money, same amount of money. So this is an apple, this is an orange, and they cost the same thing. Or apple and orange, they cost the same thing. That's what I meant. Okay. So I'm going to write negative 8x minus 19. Now, this looks really familiar. This looks like what we did about a week ago. We are now going to solve the equation for the variable, step 2. So I'm going to solve this. So first I'm going to put my line down the middle, remember? Okay, so I got 8x. So remember, I need to, the first step, if you remember the steps from the previous lesson, I need to make a zero pair with the smaller variable. The smaller variable is this negative 8. So I'm going to make a zero pair. Zero pair has a positive and a negative, and then the same number. So plus 8x. And I'm going to do the same thing to this side, plus 8x. Now I have 16 x's. And bring all my constants down. Plus 13 equals negative 19. Now I'm going to make a zero pair with the constant near the variable. Here's the variable. There's my constant. I'm going to make a zero pair. Zero pairs have a positive and a negative, and the same number. So I'm going to subtract 13 on this side. So I'm left with 16x equals, I have negative 19 minus 13. You could change this by doing keep, flip, change, because we don't like subtraction. Where's my brain? Keep, flip, change. So I have negative 19 plus negative 13. So I'm going to add these two numbers together. 9 plus 3 gets us 12. So carry the 1, so we go 2. And 1 plus 1 is 2, plus the 1 that we carried over is 3. So we're at negative 32. Last but not least, we got to get x all by itself, so I need to divide. I need to divide by 16. 16 divided by 16 gets us 1. That goes away. divide by 16, and I'm left with x equals 2. Okay, we're not done. I know you can't see. Okay, x equals 2. So now, step 3, we need to substitute and solve for another variable. So we found out what x is, but now we got to go figure out what y is. I'm like, Masabe, how do we do that? So I'm going to shift this over, remove my steps. Okay, now I get to pick. So I found out what x is. I can pick either one of these equations. I'm going to pick the one that doesn't have all the negatives in it just because I can. So I'm going to take the x plus 2, I'm going to write it up here, or excuse me, x equals 2, and I'm going to rewrite this equation so it has x in it. So now I'm solving for y. I know what x is, but I got to solve for y. Remember, our ordered pairs have x's and y's. So y equals 8 times x. X is now 2. So I'm going to put parentheses. This is how you insert a new number. 8 times 2 plus 13. So y equals, you can do your line if you want. 8 times 2 is 16 plus 13. Y equals 29. 6 plus 3 is 9. 1 plus 1 is 2. 29. So now my last step on here says write your answer as an ordered pair. Remember, ordered pairs look like this. X, comma, y. So let's rewrite them as an ordered pair. My x is, what did I figure out my x was? My x was 2. So I'm going to write 2 because that was my x. Then I need, what's my y? What is my y value? We figured that out right here. Y is 29. So I'm going to insert that right here. And that's why y is there. So this is my final answer. And that's how you solve it algebraically. So we're going to do one more, hopefully in 3 minutes. Go a little faster. Okay, one more example. There goes my mouse. Okay, so I'm going to set these up equal to each other. No, I'm not. Yes, I am. I had to think about that real quick. Okay, I'm going to set these equal to each other. So I have negative 3 halves x plus 3. I'm just thinking that we're not going to give you ones with crazy fractions, I don't believe. So that's why I hesitated to do this one. But I think it'll still work out. So x plus 4. Okay. Solving for x. So I'm going to subtract. I'm going to make a zero pair with the smaller variable. So I'm going to add 3 halves to the half, the negative half. So I'm going to add 3 halves. Now, for those of you who don't like fractions, I'm sorry. But 3 halves, the negative 3 halves plus 3 halves cancel out. So I'm going to add 3 halves over here. So now I have 3 halves, but I have to take away a half. So 3 halves minus 1 half is going to leave me with 2 halves, 2 over 2, and 2. This is why I decided to go along with this, because so I'm left with 3 here, equals 2 over 2 is just 1. So I'm left with 1x over here, which is really nice, plus 4. Now I got to get rid of this 4 because it's next to the variable, so I'm going to subtract 4. Subtract 4, and I'm left with 3 minus 4 is negative 1 equals 1x. Done. And you can't see that. There you go. Okay, got 1 minute. Don't think I can finish this. Sorry, guys. Okay, then I'm going to plug this in to a different equation. So I'm going to plug it into the 1/2 one because that seems easier. 1/2 of negative 1. So y equals negative 1/2 times negative 1 plus 4. 1 times anything is going to keep itself, but I got a negative times a negative gets us a positive, so y equals 1/2 plus 4, so y equals 4 1/2. So my ordered pair is negative 1, comma, 4 1/2. That's why I made it. There we go. Let me know if you have any questions. That one was really fast and had fractions, so I'm sorry. But let me know if you have any questions.